Hello everyone, welcome to today's class. This is just Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for October, November 2024, question paper 3-2. And this is part 2 for questions from 7 to 11. Question 7 part A, show that the equation tan cubed x plus 2 tan 2x minus tan x is equal to 0 may be expressed as tan power 4 of x minus 2 tan squared x minus 3, which is equal to 0 for tan x not equal to 0. Now using the double angle for tan, this one is going to be tan cubed x then plus 2 times 2 tan x out of 1 minus tan squared x and then minus tan x, which is equal to 0. Now we can multiply all through by 1 minus tan squared x everywhere. So that means here we shall have tan cubed x multiplying with 1 minus tan squared x and then plus. Then we shall have 4 here, tan of x. Of course, when you multiply by its own denominator, it disappears. Then minus. Now we have tan x here, which is now multiplying with 1 minus tan squared x, which gives us a 0. So opening the brackets, we can have tan cubed x, then minus tan power 5 of x, then plus 4 tan x minus tan x here, then plus tan cubed x. Okay. How can I get, now you can see that tan x is actually common everywhere. So how can I get tan x power 4? Already this one is tan power 5. Okay. So what I need to do is to factorize out negative tan of x. Okay. That means for tan cubed, it is going to be tan negative tan squared. Okay. And then this one, which was tan power 5, is going to become now a plus tan power 4 of x. And of course, now these ones I can simplify them. Okay, I can simplify them and then it becomes 3. So we shall have a negative 3 then. So minus 3. And then this other one will also be minus tan squared x, which is equal to 0. So inside here, that means we are going to have tan power 4 of x, and then power 2. So we are going to have minus 2 tan power 2 of x, and then minus 3, which is equal to 0. Remember, we are supposed to get the factors. This one we equate it to 0, and this one we also equate it to 0. But since they told us that tan x is not equal to 0, then we get this other factor is the one that we equate to 0. Part B, solve the equation tan cubed 2 theta plus 2 tan 4 theta, then minus tan 2 theta is equal to 0. For theta ranging from 0 to pi, give your answers in exact form. Now this, since they are saying hence, then we are supposed to apply what we have gotten before into this one here. So we shall have now tan power 4. Okay, now 2 theta. Remember this other one here as x. Now this one is going to be 2 theta. Okay. So in the place of x, we put 2 theta. So 2 theta, then minus 2 tan squared 2 theta, and then minus 3 should be equal to 0. This is a quadratic in tan squared. In tan squared 2 theta. Okay. So what we can do, if I have my sum here as negative 2, and then the product is negative 3. Two numbers, when I multiply them, I get negative 3, but when I add them, I get negative 2. That will be negative 3. and 1. So that means here we are going to have tan squared 2 theta, then plus that 1, and then the other one is tan squared 2 theta, then minus that 3, which is equal to 0. Then we shall have tan squared 2 theta being equal to negative 1, because all of these factors are going to be equated to 0. And then tan squared 2 theta will be equal to 3. Automatically, I will have to take the square roots, so this one will be undefined. Okay, undefined. And then we take this one here. So tan 2 theta shall be equal to the root of 3, and it has to be plus or minus. So that means 2 theta is going to be the arctan of plus or minus root of 3. So theta is going to be a half of the arctan of the positive 1 root 3, or theta can be the arctan, the half of the arctan of now the negative of root 3. Now, I always use the 4 quadrants. So when I try to use the 4 quadrants here, so drawing them, I'll have all are positive in the first quadrant, only sign positive in the second quadrant, only tan in the third quadrant is positive, only cos in the fourth quadrant is positive. So the domain they gave us is in radians. We shall have 0 here, not degrees, this is in radians. Then here we shall have pi over 2, and then pi here. Then down here we shall have 270, which is 3 pi over 2, and then here 2 pi. Then projecting this one here, maybe that is our theta, and then down here it is also theta. So this one will be pi plus theta. When you move the clockwise, you move from here up to there. And then the other one here, if I put the theta, if I put theta here, then it will be 360, which is 2 pi, then minus the theta. Opposite angles are equal. Again, when I put theta here, this will be pi minus theta. Now, root 3, this one is positive. So tan is positive in the first quadrant and third quadrant. Okay. So since it is positive in the first and third quadrants, what we are supposed to have is those 2 quadrants. So remember, here we are having a half. So before you take that a half, first get the pair of those angles. So arctan of root 3 is actually 60, which is pi over 3. Then the other one, where tan is positive, is in the third quadrant, which is pi, then plus that pi over 3. Okay. And then when you get your calculator and you put arctan of root of 3, actually you put the negative. Okay. The calculator is going to give you negative pi over 3, but we are not having the range where the values are negatives. Okay, we are dealing with positive ones from 0 to 180 or to pi. So what do we therefore need to do? Just ignore the negative. So it will give you that pi over 3. Okay, now you go to the quadrants where tan is negative. It is here and then here. So how do we get the angle in the second quadrant? It is pi minus theta. So our theta here is going to be a half, then into this one is going to be pi, then minus pi over 3. And then the other one is going to be, in the fourth quadrant, it is 2 pi, then minus that pi over 3. Okay, so simplifying this one, inside we shall have 3 minus 1, that is 2 pi over 3. And then this will be 3 times 2, that is 6 minus 1, that will be 5 pi over 3. And then also here we are having a half into the pi over 3, and also 3 times 1, that is 3 plus 1, we shall get 4 pi, okay, 4 pi over 3. So this simply implies that our theta is going to be equal to pi over 6 when you multiply here, pi over 6, and then this one can cancel with this, then you can get pi over 3. So I'm arranging them in order. So I'll put this one first, next I put this one here, and then next I'm going to have now a half of this one, so 2 will go into this 4 2 times, so we shall have 2 pi, okay, 2 pi over 3, and then lastly we shall have 5 pi over 6. So these are the 4 angles that we are supposed to have there. Number 8, the parametric equations of a curve are x is equal to tan squared 2t, y is equal to cos of 2t for t ranging from 0 to pi over 4. Part A, show that dy dx is equal to negative a half cos cubed 2t. So we need to differentiate parametrically using what we call the chain rule, okay? So dx dt is going to be, remember this one is the same as saying tan 2t then power 2, okay? So when you differentiate, you drop the power, it will be 2 here, then reduce the power here by 1, so it will be to the power of a half, power of 1, then times, enter inside and differentiate. When you differentiate tan, you get sec squared theta, that's 2t, but again the angle here you have to also multiply through by the derivative of the angle, okay, which is 2. So that means all together I'm going to have 4, this 2 times this one here, so that will be 4 tan 2t then sec squared 2t. I can actually simplify this since in here we are seeing only cosine. So tan is the same as sine, okay, sine over cosine. So we have cos 2t here, and then times sec is 1 over cosine, so that will be cos squared 2t. That means this all together will be 4 sine 2t out of cos squared, it is actually cos cubed because we have cos 2t here and then the cos squared there. So we shall have cos cubed 2t. Then we also go to y. We have y which is equal to cos 2t. Then dy dt is going to be equal to, when you differentiate y, you get a negative sign, okay, 2t. Then after we multiply by the derivative of the angle, the derivative of this one is giving us a 2. So 2, that means this one is going to be negative 2 sine 2t. Then after that, using chain rule, then dy dx is going to be equal to dy dt then times dt dx. Now our dy dt, we have gotten it as negative 2 sine 2t, then times dt dx. Dt dx is the same as 1 over dx dt. So we are going to have here 1 over our, you just actually somersault this, okay, without wasting time. So when we somersault, we shall have cos cubed 2t and then divide by 4 sine 2t. So here we shall have, of course, the 2 reduces this one to 2, and then this one here will go with this, And our answer will actually be what they have told us to find. It's negative a half, then cos cubed 2t. Okay, that is our dy dx. Part B, hence find the equation of the normal to the curve at the point where t is equal to pi over 8. Give your answer in the form y is equal to mx plus c. Now when t is equal to pi over 8, remember, when we are to find the equation of a straight line, we need to get the gradient and then at least a point through which the line passes. So we are going to have t is equal to pi over 8 substituted in x and also y to get the coordinate, okay? To get the coordinates through which the line passes. So our x is therefore going to be tan, then that 2, then pi over 8. Then after that, we square. So 2 pi over 8 becomes pi over 4, and tan pi over 4 is 1. And then when we square, we get 1. Then y is cos 2t. So 2 times pi over 8. Now cos pi over 4 is root 2 over 2. Okay. Then also when t is pi over 8, what is the gradient? So our dy dx is going to be negative a half. Remember, it was cos cubed. So we can put cos of 2 pi over 4, pi over 8. Then after, we cube this one. Okay? So when we put this one all together in the calculator, negative 1 over 2, and then times, we are having cos of pi over 4, pi over 4, then we cube this one here. So it gives us negative root 2 over 8. So negative root 2 over 8. Now this one becomes the gradient of the tangent. So gradient of the normal, remember, the product of gradients of the two lines which are perpendicular is always equal to negative 1. So gradient of the normal is going to be equal to negative 1, then divided by the gradient of the tangent. And the gradient of the tangent is negative root 2 over 8. Negative divided by negative, you get a positive. So the answer I've gotten here, we just say negative 1 divided by the answer. And this one will give me 4 root 2. So I write 4 root 2. And also now, to find the equation of that line, you know the general equation is y minus y1, which is equal to m into x minus x1. So our coordinate is 1, then root 2 over 2. So we shall have y, then minus root 2 over 2, which is equal to m is 4 root 2 into x, then minus 1. So we make y the subject. This will be 4 root of 2 of x, and then minus 4 root of 2 plus root of 2. Okay, and then finally we get the answer as y, which is equal to 4 root of 2 of x, and then 2 times 4 you get 8. So negative 8 plus 1, that is minus 7. Then minus 7 root of 2 over 2 as our final answer. Question 9 is from vectors. With respect to the origin O, the points A, B, and C have position vectors given by OA, which is 2, 1, negative 3, OB is 0, 4, 1, and then OC is negative 2, negative 3, negative 2, 2. Part A, the point D is such that ABCD is a trapezium with DC, which is equal to, vector DC is 3 times the vector AB. Find the position vector of D. Now here, vectors are said to be parallel if they are scalar multiples of each other. Now that means these two are the parallel sides of the trapezium. So if I can sketch my trapezium like this, just a sketch, that means this one can be my AB, and then this is C, then D. You have to take it in that order: AB, C, and D. But AB and DC are the parallel sides, okay? Then DC is bigger than AB, it multiplies it by 3, okay? So it has to be like that. Then DC here, I've already said that if you are to find DC, you just get OC minus OD, okay? Get the last minus the first. Then 3 into OB minus OA. So I want to get OD. That means I will have OC here minus the 3 of OB minus OA. And then this one will be equal to OD. Now the rest is to substitute. OC is given as -3, -2, 2, then -3, and then in here we are going to have our OB 0, 4, 1, and then our OA is 2, 1, -3, then which is equal to OD. So this is -3, -2, 2, then -3. When we multiply in here, when we subtract 0 minus 2, that is -2, 4 minus 1, that is a 3, 1 minus -3, that will be a 4. That will be our OD. And then we simplify now. OD is going to be equal to, now here you have -3, then plus 6. That will be a 3, okay? So we shall get a 3. And then we also have -2 minus 9. So that will be -11. And then we also have 2 minus 12. And that will be -10. So this will be our position vector of D. Okay, let me rub off this here. Then part B, the diagonals of the trapezium intersect at point P. Find a position vector of P. So if I try to draw here the diagonals, okay, the diagonals here, and also this one here, they meet at this position P. Okay, that is P there. Now that means I need to get the equation of this line BD. I also get the equation of this line SC. Okay, then I solve them simultaneously to get the position vector of P. Okay, that is the logic behind. So we need to get the equation of the line SC, okay, the diagonal SC, and then the diagonal BD, okay. So you come back here, SC, and then BD. So we need to find these vectors, the directional vectors. Actually, the directional vectors are going to be SC and then BD. So let's find SC. What is our SC? You get the last OC, then minus the first OA. So OC is -3, and then -2, 2. Then OA is 2, 1, -3. Then when we subtract them, here we shall have -5, and then here -3, and then 5. Okay, now equation of the line SC, equation of line SC is going to be, let's say, R1, which is going to be equal to OA, which is passing through the point A, then plus lambda, then SC is going to be the directional vector. So that means R1 is going to be 2, 1, negative 3, okay, and then plus lambda minus 5, minus 3, then 5, okay. That is 1 there. Then next, I also do the same for BD. So this one is going to be OD minus OB. Our OD, we have gotten it up there as 3, negative 11, negative 10. And then our OB is 0, 4, 1. So when we subtract, we shall get 3 here. The negative 11 minus 4, that is minus 15, minus 10 minus 1, that is minus 11. So meaning, now to find the equation of the line BD, equation of line BD, it is going to be, now maybe R2. So R2 is going to be equal to OB, then plus, let's say, mu, then BD. So we are going to have our OB, which is 0, 4, 1, then plus mu, and then BD is 3, negative 15, negative 11. Okay, so I have this equation here, and then I also have this equation here. So to get the position vector of the two, we are going to get their parametric equations, and then we equate them. Okay, so the parametric equations are going to be, this one is 2, then minus 5 lambda, 1 minus 3 lambda, then minus 3 plus 5 lambda, something like that. Now, there is some space here. Okay, so we equate the two for intersection. For intersection, 2 minus 5 lambda, then 1 minus 3 lambda, and then negative 3 plus 5 lambda. Okay, this one is equivalent to 3 mu. Then this one is equivalent to 4 minus 15 mu. And then this one is equivalent to 1 minus lambda mu. Okay, if we go back and we check here, yeah, you can see that we have 0, then plus 3 mu. So that's why I'm just having 3 mu. Then 4 minus 15 mu, and then 1 minus 11 mu. So that is that. Then I can get just 2 equations, and then I solve them simultaneously. So if I get the first one here, which is equal to 3 mu, and then the second one, 1 minus 3 lambda, which is equal to 4 minus 15 mu, I can eliminate lambda. So I multiply here by 3 and then here by 5. Then we can get 6 minus 15 lambda, which is equal to 9 mu. And then 5 minus 15 lambda, which is equal to 20, then minus 75. Yes, 75 mu. Then when we subtract, since the signs are the same and also the coefficient of lambda, that one disappears. So we shall have 1, which is equal to, then this other side, 9 minus 75. So it's like 75 plus 9. That one will give us 84. So we have 84 mu and minus 20. So when I bring the 20 this side, it will be 21, then 84 mu. And then what will I get as mu? Mu is going to be 21 over 84, which is a quarter. Okay, so I don't need to find the value of mu. I just now substitute in any of these. This can be my OP or this one here, the position vector of the point of intersection. So let me take this one here. So my OP is going to be 3 times a quarter, and then 4 minus 15 times a quarter, and then 1 minus 11 times a quarter. Okay, then our OP is now going to be 3 quarters here. Let me make it a little bit long. So this is 3 over 4. And then 4 times 4, 16. So 16 minus 15, that will be 1, then over 4. And then 4 times 1, that is 4. Minus 11, that is negative 7 over 4. So this will be the position vector of the point of intersection. You can even write it in terms of I, J, and K. Then you can say, OP is going to be equal to 3 over 4 of I, then plus 1 over 4 of J, and then minus 7 over 4 of K. So any of them is an answer. And then part C, using a scalar product, calculate the angle ABC. Calculate the angle ABC. So by going back here to our diagram, ABC. Okay, now this is how it looks like. So I can bring a small sketch here. Oh, sorry. Small sketch is going to be, maybe this is our A, this is our B, and then C. So B is here, A is here. So you can either find BA and then BC, or you can find AB and then CB. You either close in or you open up. Okay, so let me open up B to A. So I can use B to A, B to A, and then B to C to avoid making mistakes. So you close in or you open up. So what is BA? BA is OA minus OB. Remember, our OA is 2, 1, negative 3. And then our OB is 0, 4, 1. So when I subtract, I'll get 2, negative 3, negative 4. Okay. Then what is our BC? So BC is going to be OC minus OB. So what is our OC? Is negative 3, negative 2, and 2. Then our OB is 0, 4, 1. So when we subtract, we get negative 3, negative 6, and then 1. Then using the scalar product, that means we are going to have BA. We dot it with BC, which is equal to the modulus of BA, then the modulus of BC, and then cosine of the angle in between them, that ABC. So already we have gotten our BA. So we shall write 2, negative 3, negative 4, dot it with negative 3, negative 6, 1. Then after that, we get the length of BA will be 2 squared, then plus negative 3 squared, then plus negative 4 squared, and then times the square root of negative 3 squared plus negative 6 squared, and then plus 1 squared, then cosine of theta. So I multiplies with the I, j with j, and then k with k. So 2 times negative 3, that will be negative 6. Then 3 times negative 6, that will be positive 18. And then negative 4 times 1, that will be negative 4. And then inside here, we are going to have 2 squared, that is 4. 9 squared is, negative 3 squared is 9. And then negative 4 squared is 16. So 16 plus 9, that is 25. Then plus 4, that is 29. So we shall have root of 29. And then times, this one here is 36 plus 10, that is 46. So root of 46 cosine of theta. So meaning that cos of theta shall be equal to 18 minus 10. That one will give us 8. Then we divide by root of 29, then times root of 46. And then this therefore implies that if I want to get the angle, so that angle ABC is going to be the arc cos of 8, then out of root of 29 times root of 46. Now, here they just said calculate the angle. They never told us whether it should be in degrees or in radians. So whether you put it in degrees or radians, it's all marked correct. So I can say shift mod, then to put it in degrees, then I can say shift, now cos, then I put 8 out of root of 29, then times the square root of 46, then all of it together under the arc cos. So it will give me 77.3. This one is 77.3. That is to 1 decimal place. Okay. Alternatively, if somebody used radians, I would just come here, shift mod, radian is 4, and then I just press the equals. So that is 1.35. 1.35 radians. That is to 3 significant figures. But you just give one answer. Don't write the 2 answers. Okay. Question 10. A balloon in the shape of a sphere has volume V and radius R. Air is pumped into the balloon at a constant rate of 40 pi, starting when time t is equal to 0 and r is equal to 0. At the same time, air begins to flow out of the balloon at a rate of 0.8 pi r. The balloon remains a sphere at all times, but A show that r and t satisfy the differential equation, the r dt, which is equal to 50 minus r out of 50 r squared. Now we begin with volume of a sphere. Volume of a sphere is 4 over 3 pi r cubed. Then we need to get the v, the r. You drop the 3, so it will cancel with this one here. You will get 4 pi r squared. Now, they said that air is pumped into the balloon at a constant rate of 40 pi. Okay, at the same time, air begins to flow out at a rate of this. That means the rate at which water is increasing in that balloon is this one you use for pumping in, and then also what is getting out. So you subtract it. Okay. Have you ever poured water in the cup or in anything that is leaking? It continues to go up as also some of it is pouring down as it leaks. So some is going down and then the other is still remaining there, but the overall, the net is the one that increases. Okay, the net. So this therefore means that our dv dt, the rate of increase in the volume, is going to be 40 pi, then we subtract 0.8 pi r. So our dr dt, So using the chain rule, dr dt is going to be equal to dr dv, then times dv dt, such that dv can cancel with this one, okay? So dr dv is just 1 over dv dr, so it will be 1 over 4 pi r squared, and then our dv dt is 40 pi minus 0.8 pi r, okay? And then from here, based on what I'm seeing here, we are not having any decimal. I can factorize out something here. I can factorize, by the way, pi is common, so I can factorize out a 4 pi in the numerator. So that means we shall have 10, then minus, that will be 0.2, and 0.2 is the same as 1 over 5 of r. Then out of, down here we have 4 pi r squared. So 4 pi will cancel, and then what we shall have next is now find the LCM here. So you will have 5 times 10, that is 50, then minus r over 5, but that 5 is going to multiply with 1 over r squared, the reciprocal of this one, okay, like that. And then when it finds it there, then you get your answer as 50 minus r over 5r squared, like that. Then part B, find the quotient and remainder when 5r squared is divided by 50 minus r. So using long division, I can have my divisor is 50 minus r, actually, which I can write as negative r plus 50, because we usually write the variable first and then the constant last. Then this is 5r squared. So 5r squared divided by negative r, you get negative 5r. So negative 5r here, now we multiply through. Remember, you just divide by the first one, the rest you multiply. So negative r times negative 5r, you get 5r squared, and then 50 times negative 5r, we shall get negative 250. Yes, negative 250r. And then we can now subtract to eliminate this r squared. Remember, here we have 0r. So 0r, then minus 250, then we get positive 250 of r. So positive 250 of r divided by negative r, then we shall get minus 250. Then we multiply all through, that will be 250 of r, and then 50 times 250, okay, 50 times 250, that is 12500. So we shall have 125, so it will be minus 12500. So when we subtract, r disappears, and then this one becomes a positive 12500. So that means the quotient is the one we have gotten up there, which is equal to negative 5r minus 250. And then the remainder is going to be equal to 12500. Those are our answers here. Part C, solve the differential equation in part A, obtaining an expression for t. So in part A, we have the differential equation here, dr dt, which is equal to 50 minus r over 5r squared. So we have to separate variables when we solve this. So we have to separate variables. Now separating variables, we are going to have, first of all, my dr dt is equal to 50 minus r out of the 5r squared. So separating variables, put r on one side, this will be 5r, then we divide by 50 minus r of dr, then shall be equal to dt. Okay, Now we integrate. Now they had a reason as to why they told us to integrate, I mean to divide 5r squared, okay, by 50 minus r, because when you separate variables, you would see it here. You see that? So we divided it because the coefficient, I mean the power, we call it the degree. The degree here of the numerator is bigger than the degree of the denominator. So that is what we call an improper fraction. So you need to first long divide. Okay, that's why they told us to first divide. So now that means we are going to integrate. Now negative 5r, this is the quotient we got, minus 250. Then plus the remainder, we got 12500. Now divide by this 50 minus r. You see, dt. No. It is not dt. It is the r. I actually made a mistake here. This one is supposed to be the r, not dt. Okay. So here I write the r. Even here the r. Then we also integrate the t. Now, when you integrate, of course, this one, it will be 5, then r squared over 2 minus 250r. And then here, take this as a constant. You write 12500, then you integrate 1 over 50 minus r. Now, when you differentiate the denominator, with respect to r, you are going to get a negative 1. Okay? So then you ask yourself, what should I do to the negative 1 to get a 1 which is here? So you will multiply all through by negative 1. Now, that operation here, which gives you what is in the numerator, is what you put on the natural log. So this will be negative. First of all, you are having this 12500, and then now times negative 1, then natural log of 50 minus r. This other side, of course, the integral cancels the derivative. And then we are going to have t, then we can put plus c. So altogether, I can write it as 5r squared over 2, then minus 250 of r, minus 12500, natural log of 50 minus r, which is equal to t plus c. Now, we were given that at t, at first here, let's go back here. There is something that was given here, that at t is equal to 0, r is equal to 0. So when we come back here, at t is equal to 0, r is also equal to 0. So everything here dies. We shall have now negative natural log. No. So negative 12500, then natural log of 50 is the value of c. So this therefore means that we have negative 5r squared over 2 minus 250 of r, then minus 12500 of the natural log of 50 minus r. Then this one is equal to t, then minus 12500 natural log of 50. Okay, and they told us to obtain an expression for t in terms of r. Okay, so this one can come this other side, and then we have minus 5r squared over 2 minus 250 of r minus in fact, I can say plus 125, I mean 500. Then inside here, I can put natural log of 50, then minus the natural log of 50 minus r. I can even leave it here, okay? But I can go ahead and I have factorized this one, 12,500, okay? because this one shifted and came this other side, so it became a plus. Okay, then I factorized it. So my t, I can actually write it like this. Then my t is going to be equal to 12500. Then using the rules of logarithms, I will have natural log of 50 out of 50 minus r. Okay, like that. And then minus the 250r minus 5 over 2 r squared. That will be the expression of my t here. Then is there anything? There is part D. Find the value of t when the radius of the balloon is 12. So just substitute. Our t is going to be equal to 12500, and then the natural log of 50 out of 50 minus 12, then minus 250 times 12, then minus 5 over 2 times 12 squared. Now we can put this one in the calculator. 12500, then the natural log of 50 over 50 minus 12, and then minus 250 into 12, and then minus 5 over 2, and then this one is multiplying 12 squared, like that. So altogether is 70 point whatever is coming there. So to three significant figures, it is 70.5. 70.5 to three significant figures, and this becomes our answer. Question 11. Let f of x be equal to 2e to the power of 2x out of e to the power of 2x minus 3e to the power of x plus 2. Part F, find f prime of x, that is the derivative, and hence find the exact coordinates of the stationary point of the curve with equation y is equal to f of x. Now, this one, we are going to use quotient rule. This is u over v. And when you differentiate here dy dx, where this one is a function of x and this one is also a function of x, we are going now to have v du dx minus u dv dx out of v squared. All of these ones are given in the list of formulae. So my u is going to be 2e power 2x. Also remember that when you differentiate remember that when you differentiate e to the power of a function in x, this one is going to give you get the function, the power of that e, you differentiate it, then after you multiply by e to the power of that function. So here we are going to have our du dx, which is going to be now the derivative of this one is a 2, then we multiply all through, so that will be 2 then times 2e power 2x, which is 4e to the power of 2x, and then our v is the denominator e to the power of 2x minus 3e to the power of x, then plus 2. So that means dv dx, this one will be 2e power 2x, then minus 3e to the power of x. Okay, remember when you differentiate e to the power of x, already the coefficient of x in the numerator here is a 1, so when you multiply through, it remains. Okay, now that means that our f prime of x is equal to v, which is e power 2x minus 3e to the power of x plus 2, and then times du dx, which is 4e to the power of 2x, then minus u is 2e power 2x times dv dx, which is 2e power 2x minus 3e to the power of x, like that. Then we divide it by v squared, which is e to the power of 2x minus 3 e to the power of x, then plus 2, and then you equate this one to 0, okay? Because they say we are finding stationary points, and for stationary points, dy dx is equal to 0. Then we can simplify this, okay? We can simplify this. Of course, this one is going to disappear when I cross multiply. Now, e to the power of, actually 2e to the power of 2x is common, okay? So that means here, because I've taken it out, I will remain with the 2. So that 2 then multiplies here, e to the power of 2x minus 3 e to the power of x, then plus 2. And then here minus, we have 2e to the power of 2x, then minus 3e to the power of x. Okay, then we shall have 2e to the power of 2x, open the brackets here. You have 2e to the power of 2x minus 6e to the power of x, then plus 4 minus 2 to the power of, 2e to the power of 2 of x, then plus 3e to the power of x. Then simplifying this one will give us 2e to the power of 2x. So this one will cancel with this one here, and then minus 6 plus 3, that is a minus 3. So we shall have 4 minus 3e to the power of x here, which is equal to 0, okay? Which is equal to 0. Now, this implies that now these factors, we can equate them to 0, okay? These factors, we can equate them to 0. So you can have 2e to the power of 2x, which is equal to 0. There is no number you're going to power with e, and it gives you a 0. So this one is ignored because it is undefined. And then we can equate this one, 4 minus 3e to the power of x, we equate it to 0. That means 4 is equal to 3e to the power of x, and then e to the power of x is equal to 4 over 3. I can find the value of x, but let me just leave it here because what they have asked for here, exact coordinates, yes, we shall need the x coordinate here, and then the y coordinate. So the y coordinate, we shall be substituting in this f of x, and there is e of x in there. So what will be the value of x here? Introduce natural logarithms on both sides. Okay, when we introduce natural logarithms on both sides, we shall have natural log of 4 over 3, which is equal to natural log of e to the power of x. Using the rules of indices, this one will come down here, but then natural log of e is 1. So that means x is going to be equal to the natural log of 4 over 3. See that? Then the value of y is now going to be, we are given 2e power 2x, 2e power 2x out of e power 2x minus 3e power x, then plus 2. It should be noted that e to the power of 2 of x is the same as e to the power of x, then squared. Okay, now already we have e to the power of x here, okay, which is 4 over 3. So that means I'm going to put here 2, then times 4 over 3, then squared, and then here I'll have 4 over 3 squared minus 3 into 4 over 3, then plus 2. So what does this one give us? I just get the calculator and I put in everything. So I have 2. No, there is a mistake here. This one is supposed to be a square, not a cube. It's a square. So I will have 2, then into 4 over 3, and then I square that. I got the denominator, and then I put 4 over 3, and then I square that, then minus, of course this will be minus 4 because the 3 disappears, then plus 2. Then this one will give us negative 16. So that means the coordinates, the exact coordinates of the stationary point, we are going to have natural log of 4 over 3 as the x coordinate, and then the y coordinate is a negative 16. So this is going to be our answer. Then the last question of this paper, it's part B. Using the substitution u is equal to e to the power of x and partial fractions to find the exact integral of, they are saying use the substitution u is equal to e to the power of x and partial fractions to find the exact value of the natural log of f of x with respect to x from natural log of 3 to natural log of 5. Give your answer in the form natural log of a, where a is a rational number. That means it is given as a fraction in its simplest form. Now, the variable has changed. So u is equal to e to the power of x. Then we need to differentiate this one. So du dx is going to be equal to e to the power of x. So when you cross multiply, you express now dx in terms of du. So it will be du out of e power x. Okay. Then actually this one is the same as saying du out of u, because e to the power of x is u. Then we can also change the limits. So if x is equal to natural log of 3, then u is going to be equal to e to the power of natural log of 3. It should be noted that e to the power of natural log of a is equal to a. Let me prove it for you here. We get the calculator and we put e to the power of natural log of, let's say, 3. Okay, that is a 3, you see. So that therefore means that here we are going to have a 3. And then where x is equal to the natural log of 5, our u is going to be equal to 5. Not so? 5. Now, that means the integration from natural log of 3 to natural log of 5 of 2e to the power of 2x out of e 2x power 2x then minus 3 e to the power of x plus 2 with respect to x. This one is going to be the integral from 3 to 5. Remember, e to the power of 2x is e power x, then what? Squared. So I will have 2u squared, then out of u squared minus 3u plus 2, okay, then times du, then over u. The dx is du over u. Now this u here will reduce this one by 1, okay? And then we get the integral from 3 to 5. This is 2u out of u squared minus 3u plus 2, then du. So they said somewhere that we use also partial fractions. But now what we see in the denominator is a quadratic expression. But this one is factorizable, okay? The product is a 2. So you look for two numbers. When you multiply them, they give you 2. But when you add them, they give you negative 3. So that is negative 2 and negative 1. So that means this one is going to be the integral of 3 to 5, then 2u out of u minus 2, and then u minus 1. So with respect to u. Now, using partial fractions, this therefore implies that 2u out of u minus 2 and then u minus 1. This one is going to be a out of u minus 2 because all of these are linear factors, then plus b out of u minus 1. So we just cross multiply this and with that. So you get a into u minus 1, then plus b into u minus 2, then you equate to this numerator here, which is equal to 2, because this one sorry, this is 2u. I equate to that numerator there because this the LCM of these ones is going to be the multiplication of this, which is going to be here u minus 2 then into u minus 1, which is the same thing that is this side, u minus 2 then u minus 1. So we don't have time to waste there. So you just get this and you equate to the numerator, okay, just like that. And then you use the values of u that can terminate one of the terms, and then you remain with the other. So I can say if u is equal to 1, that means a will be terminated. Then I will have negative b, because 1 minus 2 is negative 2. I mean negative 1. Then we shall have this side 2. So this therefore implies that b is equal to negative 1. Then if u is equal to 2, that means this one is going to go away, okay? So when it goes away, I will have now 2 minus 1, that is 1. So we have a, which is now equal to 4. You see? So that therefore implies that our integration here, the integration from 3 to 5 now, 2u out of u minus 2 into u minus 1 du is going to be equal to the integral from 3 to 5 of 4 over u minus 2 and then minus 1 over u minus 1 with respect to u. When I differentiate the denominator, I get 1, okay? So that 1, I multiply it by 4 to get the numerator. So 4 natural log of u minus 2, and then minus, this will be natural log of u minus 1. And then the next thing to do is to put in the limits. So when I put the limits there, oh, sorry. Oh, I had messed up already. So this one is supposed to be negative 2, okay? Negative 2 here. Negative 2, and then so here negative 2. So here we shall have minus 2. Then put in 5. So we have 4 natural log of 5 minus 2, that is a 3. Then 2 natural log of 5 minus 1, that is a 4. Then we subtract, put now 3. 4 minus natural log of now 1. And then minus 2 natural log of 2. Natural log of 1 is a 0. So all of these are natural logarithms. So we make it 1 natural log. So we can have natural log of 3 to the power of 4 minus natural log of 4 to the power of 2, and then plus natural log of 2 to the power of 2. So this one goes up here, this one goes up there, this one is already 0, and then this one goes up to there. So I can have natural log of 3 power 4, that is 81. Then I can solve it with this one right away. So that is times, now 2 squared is a 4. Then I can divide by 4 squared, which is a 16, okay? And then this 4 can reduce this 16 by 4. So we shall therefore get natural log of 81 out of 4. And remember, they said we write our answer as natural log of a, where a is a rational number. And we have gotten it as a fraction, which is a rational number. So this is our answer. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.